I welcome you on EtherChannel configuration lesson. In this video lesson, I will make basic configurations of the EtherChannel by using the protocol the PAGP, which is the Cisco Proprietary protocol. And first of all, we created two switches, switch 0 and switch 1, which both of them are 2960 catalyst switches of the Cisco. And afterward, we are selecting the connections, and in the connection, we are selecting the automatically choose connection type. And we'll make interconnection of these two switches by using double links. So we have two ports, and it will fasten forward. Then we'll see that one port is blocked, and this port is actually the blocked port, which been elected by the spanning tree protocol. So our idea of the configuration of the EtherChannel is to create the logical channel, or to create the channel group, which will seems like a physical one link. So we are bounding multiple physical links into a logical one virtual link. So, and we will use with you protocol which is called PAGP, port aggregation protocol, which is Cisco Proprietary protocol. It means that this protocol can work only with Cisco equipments. And we have an analog of this protocol which is called LACP, link aggregation control protocol, which is actually the standard protocol. So which can be used with multiple vendors. So, and to make configuration of switch 0, we will just click on it and we'll enter to the global configuration mode. Or first of all, let me erase all of my configurations which I have on this switch, because I think that I already made up some configurations. And fasten forward time, and here it is. Now, we'll go to global configuration mode, and from this global configuration mode, we'll penetrate into configuration of two ports. They are interface range FA01-2. Well, we have to select the port, channel protocol, which have to be used, and in our example, this PAGP protocol, so we are just writing it here. And afterward, we have to select the which group will be used. So we have with you 6 variants of the numbers for the channel group, and it means that this switch supports up to 6 channel groups. So it can be, so if here are 24 ports, so you can create 6 groups, so that, and you can divide your groups to the ports respectively. And channel group 1, for example, and afterward you have to define which mode is going to be used in the PAGP. As you remember, in the PAGP there are 2 modes which are available for it. It is auto mode and it is desirable mode. So if you will configure your switch ports with the auto configuration, then your switch ports will wait for the offer to create the adjacency and to create the EtherChannel. In case if you are writing desirable, then your switch ports, switch ports of FA0 of switch 0, FA01 and FA02 will try to create an adjacency to create the EtherChannel link. Well, so let's select the desirable mode, and afterward we are able to define to see the output of the EtherChannel. So here we have the information that we have group 1, and which protocol is used. The protocol is used the PAGP. So let's take a look for the another output, show EtherChannel, and here we have summary, which is showing us that we have PO1. PO1 is the port channel name, and under this port channel name we have 2 ports, port FA01 and port FA02. And here you can see the flags which are defining the statuses of the of our ports. And in case if you already configured it, and if you don't have that the information that you have already channel which is created, then you will just take a look for the flag. This you can see I it means the standalone. What does it mean? It means that from this side switch 0's 2 ports are trying to create an adjacency with the switch 1's ports, but switch 1 is not properly configured with the port statuses and with the protocol type, and in this case we have the result like this standalone. So it means that our channel group, our Ether channel is not properly working until that moment when you will configure the second part of your connectivity, the switch 1's connectivity. So and by the way, let us name them as the switch 1, and the previous switch will name as switch 0. So we'll just write host S0 to distinguish them during the configurations, and this one is S1. So I'm saving configurations by using command do write, and now I have to penetrate into configurations of the configuration of 2 ports, FA01 and FA02, and I have to say that here we have a channel protocol which is absolutely the same as the previous configuration switch, and channel group is going to be 1, and we'll say that mode will be the auto. And afterward you may see that some changes are happening in the switch ports, and if we'll fast forward time, then our blocked port FA02 is now unblocked. And let's take a look for the output for the reports. Show EtherChannel and summary, which is showing you the P status and P status here. And what does it mean? It means that port is so it is in the port channel, so it means that it is properly working. So if we'll take a look for the switch 0's output, so then show EtherChannel summary, which is showing us the same P and like this. Alright, and as you see, our ports are working properly. I mean, we don't have any blocked port. And in case if you will make connectivity of the new switch, so let's select the switch 2960 one more time, and let's say that we will make interconnectivity between switch 0 and switch 1 by using the ports like this. So FA03 and FA04. So let's just move it to the right side to see the ports FA03 and FA04, and from this side it is FA01 and FA02. Well, now it's time to make configuration. I mean, let's wait. So look, our port FA02 is now blocked on switch 2, and let's create a new channel group between this ports, so that we had here a configuration of the channel group. It was group number 1, so let's create the channel group 2 here between switch 0 and switch 1. So we'll just as in previous example, we'll penetrate into the configuration of switch 0 into configuration of range of the interfaces FA03 and FA04, and afterward we'll also define which protocol is going to be used, and it's going to be PAGP, and afterward we'll define which group is going to be in use. The group will be number 2, and we'll say that mode of this group is going to be the desirable. Alright, this is all configuration of our switch 0 to create the channel group number 2, and in switch 2 we'll make the same configuration. Enable and configure terminal, and also we have to distinguish our switch by using hostname configuration of the switch 2, and afterward we'll define interfaces FA0 interface range FA01 and -2, and we'll say that channel protocol which will be in use is going to be PAGP protocol. PAG channel protocol PAGP, sorry, and channel group is going to be group number 2, and mode is going to be, so you can select or desirable, or you can select the auto, because both of them will create an adjacency in case if our neighbor is in desirable mode. So, and we will just select an auto. We'll save the configurations, and now it's time to take a look. So look, also we have here all 4 ports between switches are in non-blocking state. So, and if you'll take a look for the EtherChannel summary, then you will see, then you realize that you have PO2, it is actually the name of the EtherChannel, and the protocol which is in use PAGP, and FA01 and FA02, 2 ports are in the status with the status of P, which is saying that the port in the port channel. And now it's time to take a look for another example. So we'll just make interconnection between switch 2 and switch 1. So let me just paste it here. So we had with you channel group 1 and channel group 2, and now it's time to interconnect switch 1 with switch 2. So which ports are going to be used in automatically cable selection? So here we can see port FA03 and FA04, and from this side also FA03 and FA04. So in case of interconnectivity of switches in this way, you may see that 2 ports are blocked, and here we may realize that here we have the impact of the spanning tree protocol, STP, and as you remember, STP prevents the looping on layer 2, so that when you are interconnecting your switches with the EtherChannel, so that your STP will try to block 2 ports. So let's create here channel group number 3. So we'll write a channel group 3, and let me just place here the circle which is defining this channel group 3. And now it's time to make configuration of my switch number 1. So let me just write here that interface range FA0, 3 and 4 are going to be work with the channel protocol. So we'll use same protocol PAGP, and we'll say that channel group is going to be group number 3 with the mode of the desirable, and rest switch 2's configuration is going to be absolutely the same, but at the end we'll just define that our ports are not going to be desirable but are going to be placed in the auto mode. So interface range FA0, 3 and 4, channel protocol 3, PAGP, sorry, PAGP, and channel group is going to be group number 3 with the mode of the auto. Now let's so look, I fast forward time, and now let me just realize that switch 2 has the channel group. So show EtherChannel summary. Let's realize that we have channel group number 3, so we have it, and it is in the, so you see it's active, it's in active state. I mean, it's like port in the channel group, so it means that EtherChannel is already working here, but we may see that STP impacted into this topology and is blocking the port due to that fact that here we may have the loop. It is same as you have the topology. So let me create a new topology. It will not take long time. So we have switch number, which number is going to be number 3, switch number 4, and switch number 5. Then we'll make interconnection between switches, and like this, and STP will block one of these ports. Okay, due to that fact that it is preventing the loops, it has to block one of these ports. And look, from this side we also have the STP which is working, but instead of blocking of one port, it is blocking 2 ports, because in case if two ports will not be blocked, we'll have here the loop. But other ports are not blocked because each of this circle defines the logical channel, the logical port. So, and if you will have, for example, for in each group by 3 cables, then 3 ports are going to be blocked by the STP. And if you'll take a look for the spanning tree, so let's start to reviewing spanning tree on our second topology. So we'll just write the configuration, we'll just write the command show spanning tree, which will show us that the root ID is looking like this. So, and this switch is not root because its MAC address of the bridge ID is different. And we have port FA02, which is alternate and it's blocked as you see. So, and if you'll take a look for the STP output of our first switch, show spanning tree, then you will see that also look, the root ID and bridge ID are different, so these MAC addresses are different. And we have here, instead of having physical ports, here we have the virtual links, virtual channel groups names, like channel group PO1 and PO3 are actually in each of them we have by using 2 ports, but in the spanning tree topology table we see only single. Instead of having 2 ports, we see only the group name, and group PO3 is now in the blocking state. I hope that this video lesson been informative for you, and in case if you have any questions of understanding the lesson, please do not hesitate to contact me by my email addresses, and see you next time.